welcome to everyone. My name is Jochen Walschaers and I will be giving you some insights in the mine detection system that we have and that we operate. My background is in manned aviation, been an instructor pilot for quite some time, and since 10 years we are involved in drones. The systems I'm going to present to you for this afternoon is based on two principles. So on the left-hand side, on the top-hand side, I'm going to talk about the GPR, the ground penetrating radar, and on the other side, lower right, we have the Magnetodetector. Why these two systems? Well, it depends on what kind of mines that you're looking for, metallic or non-metallic. So therefore, we need to find a certain solution for a certain problem. So I'm going to discuss both of them, the advantages and the disadvantages of one or the other, and explain quickly what it can detect and in what kind of ranges. If you have any questions during the presentation, feel free to ask or interrupt me so I can immediately give the answers so you're with me during the whole presentation. Right. So it's a drone-based system, so I'll start off with the carrier platform. Right now we use a carrier platform which is based upon the DJI Matrice 300 and 350. You see it flying right over here, and in the back, I'll show you later on, we have the example sitting. The carrier drone is supported by a ground control station where the pilot is able to steer. I want to emphasize from the beginning, it's an autonomous system. That means if you launch it, it can fly on itself and it doesn't require any interference from the pilot during the flight. So setting up the mission, preparing the mission is of most crucial importance when triggering the mine detecting. In addition to the ground control station, we have an RTK ground station. What is it used for? Well, the RTK ground station is an important element in terms of accuracy. We are right now using GPS to steer the drone, but in terms of GPS, you have an accuracy of about 3 to 5 meters, which is not enough if you detect the mine. We want to make sure that we are in the vicinity of the mine within 5 to 10 centimeters. And that's an extra augmentation system that we get via the RTK ground station. A lot of people ask me, is it really necessary to use it? In my opinion, yes, if you want to be very accurate. Yeah. So it's an extra system that you can mount on the side, and it has the same distance, it has the same range compared to the ground control station to steer the drone. See? So that's basically one important element, one important factor. Now, in order to gather the data and to store the data, we need a data logger. So on the carrier configuration, we put a data logger, an onboard computer to process everything, and then in order to stay safe from obstacles, we need an obstacle or ground sensor. We do it basically in both ways. Our system has been tested and is operational right now in Ukraine. So I gave there 2 trainings at the beginning of this year for the guys over there in order to use the drones in combination with the dogs. Today we're going to focus on the drones, and here in the field that you can see on the right hand side is where we did all of the tests and trying to detect as much ornaments or as much of pixels as possible. So that's basically the system that we use. Besides Ukraine, we also have been testing the systems in Nigeria and in Burkina Faso in order to have different scenarios, different settings. I would say Ukraine is the easiest because it's a large field, not a lot of obstacles, and if we can fly high enough, we can do a lot of acres in one day. So it's really efficient. When you're in forest areas, then the obstacle sensors are really, really important in order for the drone to actually avoid any obstacles. Okay, furthermore, this is how our setup looks like. What are the different elements that are put on it? I'll start with the forward radar. And the forward radar is basically positioned up here. So it gives us horizontal guidance, horizontal safety. It can detect small obstacles, so it's capable of doing that, while dark, rainy, foggy, whatsoever. So these radars are a very good addition to the obstacle sensors that are already on the standard drone. The disadvantage of the standard sensors on the drone is that optical steered. So if it's kind of rainy, foggy, if it's dark, then it has a lot of is an extra sensor, will provide us extra safety. The drone will automatically brake when something is detected, and as I said, it works in all kinds of conditions, so even at night you can fly the drone. Okay. Second sensor is downward radar. This is an important element, especially if you have like up and down going terrain. So you want the drone to stay at a certain altitude or a certain height above the ground at all times. So the system must be able to detect the ground and actually follow the orography. This is achieved by using the downward radar. It's basically the same as the forward radar, but it's positioned here on the front. So it actually looks down, and we as a pilot, we as a planner, can define in the beginning what the height should be above the ground. This really depends on the kind of UXO or the kind of mine in general that you're looking for. So size is of importance. And which kind of sensor you use. With a magnetic sensor, you can fly a lot higher. With the GPR, you need to fly lower in order to detect even the smallest obstacles. Okay. And then, last but not least, which is positioned on the drone, is the skyhook. Basically, this is kind of the planning brain, as we call it. So it gathers all of the information, it provides the drone with the necessary route to fly, and eventually any adjustments made by the pilot during the flight. So this is a very important element, the skyhook during the flight. Okay, so that's basically the setup and how it's set up. We will start off with the magnetic sensor, which is also behind, and I'll show you later on after the theoretical presentation. So what you see right here is the Magnetron R4. This is the latest version of the magnetic sensor, and it's equipped with 5 sensors which detect a deviation in the magnetic field, in the Earth magnetic field. That's basically what we are doing. So the larger the metallic object, the easier it is to actually detect it. If you have a very small landmine buried 15 to 30 centimeters under the ground, we need to fly a bit lower, and the magnetic imprint in the result is a bit less defined compared to a big anti-tank mine, for example. If you overfly an anti-tank mine at 3-4 meters of height with this system, it immediately gives you a very big indication something's wrong at this position of location. So the height really depends on the size. So we have 5 of them. You would wonder, it's not really easy to maneuver with this thing. Why so wide? Well, because we use this 2 to 2.5 meter size magnetic detector, we are able to have less tracing lines next to each other, which means that flight time is reduced. If you are very well trained and there is an open area, you can actually scan about 30 hectares in one day, which is quite a lot with a magneto. And then you're capable of detecting anti-tank mines, anti-personnel mines, and you get a very nice overview at the end of the flight. We are not just limited to one battery. We put in the battery, when the battery is almost depleted, drone comes home, we put new batteries in, and we resume the flight. In that way, it doesn't have to restart or see, okay, where did I end? I need to restart the mission. Everything is actually based upon the hot swap function, and the drone goes again. That's the idea behind it. So that's the data logger. Here we have the skyhook, we have the magnetic R4, and in this particular example, there is no extra radar mounted on top, but it's an option, and I would recommend it, especially if you have a lot of obstacles in the vicinity. Okay. So on the right-hand side, what you see right here, this is the RTK base antenna, and in my opinion, it's an important element that you need to have on the side of the pilot at all times to improve the accuracy. If you are flying with this system, for example in Europe, it's a lot easier. Then you can leave it out of the equation and use the surrounding RTK antennas, just like a surveyor. But if you are working in a war area where probably all of these systems have been terminated, then you can have your own georeference system, centimeter accurate, where you're putting this next to the pilot. So this is basically an augmentation system that we use. Highly recommended. Okay. What kind of objects can we detect? So this is basically an overview of what to expect of the system if you use it in the right way. So to start up, we have detection depth below the surface, and every value is expressed in centimeters, so that's important to know. And we are using the column MK2 high precision. So we use the high precision sensors. So this one is of importance. So if we are looking at 20 millimeter projectiles, you can see that with the magnetometer you can go up to a depth of 1 meter. And as the size of the target type increases, you'll notice that also depth increases. So for example, if we are looking for a 500-pound bomb, you can detect it up to 7 meters deep. So it really depends on how big the metallic structure is. This is basically the most important element to determine the depth. Now, in most cases we are looking for anti-personnel, anti-tank mines, and usually it's not very lower than, as I said, 15 to maybe 1 meter of depth in order for us to detect. What also is important is the orientation. How is the UXO, or how is the bomb, or whatsoever, how is it orientated? So if you have a vertical orientation or a horizontal orientation, you can immediately see it has a large influence on the possible detection of the mine, or whatever is buried underneath the ground. So this is what we can expect. Any questions so far? Yes, sir.
With Jochen Walschaers from University of Ukraine, you was speaking about the magnetic effect. But for instance, in the mines called leaves, which we saw today, there is a very small part of metal. So that what the minimum metal contained, you can detect what it is.
We can detect. However, for such mines, I would highly recommend to use the GPR, the ground penetrating radar, instead of the magnetic radar or the magnetic sensor. So it really depends on what you are looking for. Sometimes we put them in parallel because the magnetic goes a lot faster. Maybe it detects, could be, because even very small objects, and especially these ones, are just flat on the floor. They're not buried 15, 30 or 1 meter underneath the ground. So maybe the magnetic sensor can detect it, but then the GPR would be able to pick it up. Yeah.
And do you understand correctly that after all this research, you just compose some kind of mapping of the minefields which could be used to demine?
Yeah, that's correct. Indeed, yes. Okay. On the other hand, as I may proceed with the presentation, we have the ground penetrating radar. The one we have represented right here is the 1000 NG. That means that we are using the 1000 megahertz frequency. Why this one? Well, because it's very specific for small objects. If you are looking for larger or bigger objects, we will use another GPR using another frequency. I have a very nice table later on that provides you a good overview on what to expect on what kind of frequency. Okay, so this one is basically made up in the same way. The only thing that we do is we take the magnetic sensor out and we put the ground penetrating radar in. The rest can be as it is. So we have the same drone, the same obstacle sensors, with the same sky hub, roughly the same configuration, and then the only thing we change is the GPR. It takes you about 10 to 15 minutes to swap from one sensor to the other. However, if time is an issue and money is not, I would recommend to have two systems in parallel, so you have a fully set up magneto and a fully set up GPR in place. Maybe you can work in two teams that can overlap one of the other to have a very good overview of the actual situation. Voilà. Very good. And again, highly recommendable is the RTK antenna on the right hand side, also to give very precise information on the location of the UXO or the mine in general. Voilà. This is what we can expect. So on the top I have here the different kinds of GPRs with a different kind of frequencies. You can see right here the 1000 with the 500, 124 and the 80. So depending on the frequency, we can look or search for things that are underneath. For example, with the Cobra, they were able to detect a B-52 bomber underneath the ice 150 meters deep. To give you an idea how deep it really goes and how far it penetrates. On the second line, we have the penetration from the surface. So that means if you take a surface, how deep can it actually go into the ground. So for the 1000, we can go 1 to 2 meters. I must adjust this number a little bit. If you go to 1 to 1.5, that's probably the maximum depending on the type of soil that you're dealing with. Also important. And as you can see, as we move up to the right hand side, penetration depth becomes deeper and deeper and deeper. These values are based upon normal soil, so there are some sort of specifics. If you have, for example, ice or frozen surface, you probably get a lot deeper than these values. This is just based upon normal soil. Okay, the penetration from the drone, this means or gives an indication at what height above the ground it's recommended to fly. So, because of air also being a resistance in the detection of the mines, you see with the 1000 high frequency, it's advised to fly 30 to 50 centimeters above ground. So it's not a lot, it's roughly something like this. If you decide to fly higher, then it has a repercussion on the penetration of the surface. So you will be able to detect less deep. That's basically the idea. Okay, and then on the lower side, this is of real importance. What can we actually detect? Well, if you look at the Zond 1000A and you want to go 1 to 2 meters, you can detect obstacles, or you can detect mines, about 7 centimeters in diameter. So that's what you expect from the GPR. And it's really up to the client to decide, okay, what am I looking for? And based on that, we are going to select the right GPR to use during the operation. Okay, good. So that's GPR. Now everything is positioned, set up and so on. This is the most crucial part, which is mission preparation. That's where we start with. And not just go into the field and start flying, no, preparation is most important. And I see during the training that I give that people go too fast in the preparation. If you do this right, it will give you a lot of time saving in the field itself. You can do the mission preparation wherever you like, and then arrive at location to start flying. So, what do we recommend in terms of mission preparation? First of all, we are going to define an area of interest. We say, okay, this field, or this area, we want to map out and we want to see if there's something buried or on the surface. We set the mapping parameters. In this picture, it provides you a good idea. So this is basically the first lines that a mapping drone are going to fly. You read it correctly? It means that you have to use another small drone prior to the big one to have an accurate situation of the area. The advantage here is that if you use satellite images, they are or blurred or not up to date. Maybe sometimes 6 to 1 year old, or sometimes even older. So it's not really usable. So therefore, we use a very small drone and start mapping out the area. To give you an idea, it takes about 2.5 minutes to map 10 acres. This is quite a lot. The drone flies really fast at an altitude between 1 to 120 meters. Very cheap drone, very basic. After the mapping flights, we start processing, and if we have done the processing, we have a geotiff layer, which means that we have an up-to-date chart, which we can put on top during the preparation of the Magneto drone, or GPR drone. You're probably thinking, oh, what a kind of hustle, how long will this take? This takes about 10 minutes to complete. So the processing is really fast, we don't need high resolution, and 2 centimeters per pixel is more than enough information on the ground. But so that we have a rough idea, where are the roads located, where are the trees located. So afterwards, if we detect something, we can reference it in the situation that there actually is at that moment. So it's a very important step in the mission preparation. Step 1. Okay. Here you can see what we use. It's a widely used drone, the Mavic 3 Enterprise, very fast, with a mechanical shutter, which means that it flies 15-16 meters per second and captures very accurate data. Important that we use the same reference system as that we are going to use with the GPR, with the Magneto, because otherwise you're comparing different kind of locations. So yet again, a very important element during flight preparation, and to align both data sets of the situation, the orography, and detection of a possible mine or so. Well, and this is what you get. This is not an image from a drone at very high altitude. This is not a satellite image. It's an up-to-date image of what the situation is. It's completely geo-referenced. If I zoom in, I can zoom in to 2 centimeters precision. So this is what we generate before the flight. What I do in the next step, I take this picture and I put it into my flight planning software. So I don't have just a Google Earth view, but I have an up-to-date view of the current situation, how it's made up. So we do an obstacle map, we indicate where the obstacles are, so that the drone doesn't even fly over there. We set up the survey lines. This is the line that the drone will start flying when the sensor is mounted underneath. And the width or the spacing of the lines depends on the size of the sensor. So right here we have a separation of 5 meters between each line. Why? Because we have a very large sensor. So it detects, it shifts 5 meters up and it starts detecting over here. So the larger that the sensor is, the less lines you have to fly and the faster the process goes. So that, for me, is a major advantage of the magnetometer because it's a very large sensor. There are actually 5 sensors positioned next to each other. Okay. So that's how it's set up. We plan it, we send it to the drone, and then it actually starts to fly the units. What with very high orography, as you can see right here, mountainous areas, no problem. The sensor underneath detects the ground, and when the ground is coming up or going up, the drone actually starts following the mountains or the valleys or whatever is necessary. So this, as you can see, is part of the flight planning. This is step 2. There's no difference basically between the setting up for the mission planning for the magneto and the GPR. The only difference is the separations between the lines. So for the GPR, if you're flying at 50 centimeters high, the track can be only 50 centimeters. So it's 50, it shifts 1 meter, and then it covers 50 again for the overlap. So it goes slower. That's basically a fact for the GPR. Again, you don't have to send anyone over there. You don't have to do it in a manual way, so you have a lot of safety as a precaution. Okay. What about the speed? The speed is roughly not important because the sample rate that we take, the amount of measurements per second, are so high that we can fly 3, 4, 5, 6 meters per second, if required, in order to have good data. Everything depends on the amount of obstacles. If you have a lot of obstacles, it's not wise to fly at 5, 6, 7 meters per second. The drone needs some distance to actually be settled. Okay, good. So then, we are ready for the flight. So after the flight planning, it's up to the drone to start the actual flight. And after the capturing, we will start with the data processing. I will already give you a small insight on how the data processing goes, and then afterwards we can have a look at the drone in the back of the room to give you some real-time explanation on how everything is organized. So, with the data processing from the magneto, the principle is as follows. We have captured all of the data, and we download it directly from the sensor. So it's a Wi-Fi connection, we download it, and we put it in the first program, which is a PMXLF file converter. So what we basically get in the beginning is the lines that we have actually been flying. Afterwards, there are a lot of lines who are not of importance. We can eliminate, so I put here in red, I hope it's visible from the guys in the back of the room. So we can eliminate a lot of tracks in order to have data that we're not going to use, to leave it out, to improve the processing time. So, Magdrone data tool sets, we set the parameters, we start processing, and then, first of all, we get a quick preview. If there is nothing detected in the quick preview, you can skip all of the rest. So it gives you a very good idea, is this a zone which might give us some danger, or provide danger? And if there's nothing in the quick preview, you can go to the next zone. Also, this process, uploading as one, takes no longer than 5 minutes. So again, if you have a unit operating this, there should always be one as a pilot and one on as an observer. And while the pilot is flying, the observer is able to maybe start processing all of the data. So that's the preview. If you see, there are some hotspots, and as you can see, I highlighted it here in red, and the system does this automatically. There are a lot of spots, a lot of places that require further investigation, especially this one over here. So big red dots, like this one, and the alternation between blue and red is something that indicates there is a metallic object at that location. Could be a chain, could be a nuxo, everything which is metallic. It takes everything which is metallic. Okay, we can improve the contrast, and this is, in the end, my final chart that I'll start looking for any foreign objects, like this one, this one, this one. These are all possible hits for the targets that I should investigate, and especially this one right over here. Afterwards, if you are satisfied with, okay, this could be something, then we can export it as a hieroglyph to QGIS, which is a free program. It's a geometry program, and there you can actually project the situation on the actual chart, and you can get accurate GPS data. And with this accurate GPS data, you can locate the mine or something else. That's up to further investigation. Okay. So, as you remember, we started with this area, we mapped it out. I did a quick flight over it, and there are some elements like this one and this one. Here we have buried two metallic objects, and right over here there might be something in the ground. So these two areas especially need further investigation. So what you actually do is you overlay the detection with the kind of stitched picture that you took at the beginning of the flight. The area doesn't matter. If you have 100 acres, 200 acres, the system can easily process. It's cloud-based or it's local-based as you want, but it uses not that much of storage capacity. Okay. And then later on, even based on what you have detected, we can also make a calculation of the objects and look at, okay, how big could the object be? In further, and I'm talking future now, in further steps, we are going to develop, that's the intention, something around AI to be able to detect or define these elements based upon the footprint. But for that, we need a lot of data acquisition, testing, and machine learning before we get to this AI. Okay. To give you an idea, these were the tests that we executed. So on the left-hand side, you see the type of UXO or mine or rocket. It's also something that's been put into the ground. You see the depth at which it has been detected. This is the weight. We have the dimensions, and the Y in green means that we actually detected this ornament. So that's the object detection range. Right. So that was quite satisfying. And again, the magneto can do it very fast, very quick, very accurate. But if there's a lot of metal in the ground, he also will indicate other metallic objects. We cannot get this out of the equation. Alright. Processing GPR data is a bit more difficult. It requires some training, but still it is possible to do. So after generating GPR data, we downloaded it from the Skyhub. First program that we put it into is GeoHammer or Prism. We start processing, and this is basically the raw image that we get. Even I cannot make anything about it. We need to get it through some filters. So these filters are preset, predefined for your type of operation. So we amplify the signal via gains. We get it to a high-pass filter, and in the end, we get this image. And what we are actually looking for are distortions in what should be a horizontal line throughout the capturing of the data. To give you an idea, on the x-axis this is distance, and on the y-axis we have depth. So that's basically how it works. So the lower you see any deformation, the deeper it is. To give you an idea, if I were to analyze this picture, I would start looking over here. We have an anomaly right here, right here, right here. potential risk. Again, what is a disadvantage of a GPR? It also detects stones, for example, or wood in the ground. We could solve this by using a higher frequency, so that the wave actually goes around the smaller stones and only detects bigger or larger objects. So it's really up to the client what he's actually looking for. And in the end, we do the visualization, because what we do is we indicate this right here, say we mark it, and it's being automatically transported to a chart. So we don't have to do anything else. Okay, here, here, and here, and then it actually gets you a bigger image, give you an idea. Also, bigger image. It gets you this situation. So over here there is a gutter installed, so it detected this one. And then this was a lot of stones. So what we do in the next phase is try to put some gains and filters in order to get a more accurate map, and maybe put it in overlay with the magneto, so that we can actually detect where any potential hazards are located. But as you can see, a GPR is a bit more difficult to actually analyze compared to the magneto. It requires some training. So during our test, this is the one that we used. So it was a Russian anti-tank mine, buried at a depth of 30 centimeters. And this deformation, this is enlarged, this deformation is actually the indication that something was in the ground. So in general overview, now we put the GPR next to the magneto. So as long as depth of burying is not that deep, it's very easy to detect with the GPR. Once you go to 3.6, 2.5 and 3 meters, it becomes more and more difficult to actually detect it. And if we want to detect these ones at these depths, we simply use another frequency. We go to the 500 or the 250 or the 160, really depending on what we're looking for. Right? So, this is a quick technical review on what the system is capable of doing. Are there any questions? Please feel free to ask.
In Ukraine, we have quite a combat circumstances. The things you are speaking about in this calm situation, I mean, you have a time to fly over, and so on and so forth, but how can you provide some kind of resilience of the drones? I mean, because in the area of real combat, the enemy often use the electronic warfare against the drones.
Yeah.
So that what's about the use that in the real combat circumstances? Have you such an experience about it?
Yeah, that's really difficult because we are using an off-the-shelf drone, which is the Matrice 300, 350. So if you're planning to use this system and you need a shielded one, then you basically need to change the carrier platform. So that, and it's a problem with all drones, you can put whatever drone in such situation, even for photography, videography, and infrared images. I can never say that it will not be jammed, because communication is always on the frequency 2.5, 5.8, or whatever is in between, and jammers, they use frequencies going from 400 megahertz to 6.8, maybe 8 gigahertz. So it's difficult to operate while a jammer is in the area. I don't have a solution for that, and I think right now on the drone market, there's not really a drone that can operate without any jamming. Yeah.
So there is always a risk to lose everything.
That's right, yeah. Now, the good thing about this system is that you're flying very low altitude. As you know, these systems are on high frequency, means line of sight. So as long as you fly at low altitude, it's very difficult for a drone detection system to actually detect the system. So that's an advantage. You're not flying 120, 150 meters high. So that's, in my opinion, the only way to kind of avoid it, to fly as low as possible. But if you're flying it in between front lines or on the front line, I think that's very difficult. This system is more created, let's say not post-war, but if you gain land, you say, okay, this is the new front, to actually start to eliminating the mines or detecting the mines which are behind the front.
And another question, do you expect to create some kind of joint venture with Ukrainian companies to proceed that technology?
It could be. right now we are about 3 to 5 years busy with this project, still investigating and so on, but yeah, track record proves that the system works, and right now we are focusing improving, and maybe later on we can see on a local basis what is necessary in order to provide a better solution, because this one we can put it in Ukraine, we can put it in Nigeria, Burkina Faso, we had some questions about Mexico, so we're trying to create something general. Now, in the back of my mind, I know for a particular situation there could be other solutions. For example, Africa, it's better to have a ground rover. In Ukraine, I would definitely use a drone because of the very large area without any obstacles. But what could be improved, for example, is flight time of drones, and then maybe the non-Chinese factor to get this one out of the equation, so that you're flying basically on your own platform. That could also be something of importance.
That could be interesting from a purely practical point of view, because right now, European Union, for instance, at least declared an intention to provide some kind of money for companies, Western companies, making joint ventures with.
Yeah, indeed. We did a couple of things for the European Commission. I've been in Ukraine for this project and training the military over there. We're very happy about it, but we still are thinking how to improve the system. And there are points of improvement.
Represented all this stuff to European Commission.
Yes. Yeah. So they are where they should be. And that's also Jean's part of it, to be the glue.
Create awareness.
Yeah, in that create awareness. And to get our story in the open and to show the people what we're capable of doing. Because right now, okay, this is a very controlled area, we're going to let the drone fly. To me, it's more important to show you the data sets that we gathered, for example, in Ukraine, for example, in Ouagadougou and these areas. This is actual footage. And there are right now 4 systems, I think, flying in Ukraine. So we started in Kiev for some demonstration. We moved to Bucha. And from there on, I left the guys, and now they are trying to fly the system to as much places as possible, giving me feedback, what works, what doesn't work. So it's a very good collaboration. Yeah.
Huge market there, especially on the regional coast.
I know. Yeah. We keep improving and keep putting ourselves in the visibility of European Union.
Just a question,
Yeah.
talking about jamming those drones. I mean, you start up every, I would say, operation or application by sending out your little drone, do something fast, a couple of minutes.
Yeah.
And you map it. You map your zone.
Correct.
Would it be possible to use that information, the mapping, to make your mine detection drone fly based on the mapping, on the pictures it takes, without having radio frequencies or GPS signals to be
Yeah.
used, and then
Ground recognition.
and not being able to be jammed at that
Yeah.
stage? I mean, because that's part of your process. You are doing the mapping, so it's not something you need to do extra.
Yeah.
Can you maybe create this information, put it in the other drone, and let them fly on the pictures on the map?
Yeah, for sure. Nowadays, to give this in reference, if you want a drone attack, you do not base it on GPS, you do not base it on the radio frequencies, but you actually map out the area, you recognize trees and buildings and so on, and you do the drone navigation based on that. So that's what's the question. Now, the problem a bit with the drone that we have, if it flies very low level, I would assume there is not a lot of reference for the main drone to take in order to keep his navigation. So, but there could be some solutions. Yeah, it's maybe a good thing to put into practice. Yeah. Each time when I give this presentation, I get new ideas. So thanks all. I will take it to the drawing table.
Maybe a couple of questions.
Yes.
So I can imagine that this has been rigorously tested.
Yeah.
It's now being tested in Ukraine.
Yes.
Do you have statistics about detection ratio or percentage of detected metal? What is it? Is it 90%, 99%?
Well, with the Magneto, it detects 100% of the UXOs when within range.
Yeah.
That's obvious. But sometimes it
There are
also
deviations.
detects other metals.
Yeah.
So maybe we have 40 hits where 10 of them are pixels, I can say, okay, it's a 25% accuracy. That's not really correct. It's 100% accurate. The only disadvantage is that it also detects other things. With the GPR, we have a detection, let's say, certainty of about 80 to 90%. So it detects a lot, and sometimes the operator says, okay, no, that's a stone, and sometimes it's not. So it should, if they investigate this probability rate would be a lot higher. So that this system and the sensor, it detects everything, but in a lot of cases, too much. But I would say it's better to detect too much than too little.
But this is exactly my next question. So I see the business model as follows. So we have lots of agricultural lands in Ukraine polluted by the mining.
Yeah.
And our farmers, they are desperate to the mine, so there is a huge amount of work. And how this could work, so there could be teams of people, maybe set up companies who would offer this as a service. So let's say that they would purchase equipment from you, they would get training, support, and they would do this work. But as I see it now, based on what you showed, so what this team would deliver to the farmer is a picture of the data. There would be lots of data, but it doesn't say which mine.
Yes,
because you need to add machine learning to this.
Yes,
right?
But to me, it's the responsibility of the team not only to detect, but also to verify and to make sure that they give a probability rate. Okay, this is what we think is a mine. So it's not only the flying, it's not only the planning, but also teaching these guys how to make a correct interpretation. And I'm saying machine learning, okay, but what I'm doing when I'm over there, I'm also trained. So basically I can do the same thing, only a machine can do it a lot faster. So these teams should also be able to make a correct interpretation and give locations where they think that a high probability of a mine is. And not
Okay,
only
and has this been tested, basically? Have you cleared terrain, giving pictures, and then another team comes of the miners and clears
that's
the
what the
territory?
military in Ukraine is doing right now.
And what was the percentage of... can we
difficult.
say, or you should continuously do this several times until you actually
Right now,
clear the terrain?
again, we have only 4 systems. We are trying to keep communicating with the guys over there, but teams are shifting all the time. So to me, it's not easy to have accurate data. It's also not easy to get the mines over here. That would be great. Please give me mines, put them over here, and I'll start doing research and testing and how to put the thing in process. But that's not that easy.
Okay, can you buy this missing piece of equation to buy machine learning data on all the types of the mines used by Russians?
That's what we are looking for right now. Again, we are 2 years into the process.
Yeah.
Everything works. My team can identify where the mine is. We learned it to soldiers in Ukraine. They are also capable of doing so because they have GPS location and they give the GPS location to the demining team. And most of the time they first verify it with a dog, for example, to make sure is it actually that location. And then they go to this GPS location. Within 5 to 10 centimeters of accuracy, if you use the RTK antenna. Yeah.
Okay, and maybe the last piece, if you want to provide end-to-end service, is also actually the mining. I've seen videos of technology where drone with actually robotic arm brings an explosive after you have identified, with millimeter precision. So they push explosion and then they explode remotely, detonate.
In a field, that's no problem. Then you actually do destructive clearing up.
Yeah.
But if you want to do a non-destructive clear up, especially in cities with roads and so on, where still people need to go and you don't want to pay a lot of repairs, then this becomes a bit of a problem. But yes, in rural areas, this could be a solution for sure. Yeah, or get something to drop from high in the sky, so it has a lot of kinetic energy or potential energy to start with. This could also be a solution to detonate the mine.
Okay, thank you.
But I find the solution with the dogs very interesting because you send them out to that location, the drone just drops something which triggers the dog. Usually they follow a rope, so you lay down a rope with the drone, they follow the rope and they know at the end of the rope they should check. So that's the demonstration that I saw in Poland that was implemented in Ukraine. So there's a lot to think about, but I must say the demining part is not really right now our focus, but it's something that we need to think about. What's the next step? Yeah, you're absolutely right.
Okay, thank you.
Just thinking about the next step, it's quite a strange question. We know that the mining itself is quite expensive process. If we use your technology, how much cheaper it will be to demine at least one piece of mine? Don't you calculate that?
Yeah, what's the price of a human life? I would say.
Maybe
Yeah,
per
it's
square
how
meter,
it-
what is the
it's how
price?
it's,
Like this, yeah. So what's the price per square meter?
Yeah.
Well, I think it lowers with the amount of square meters that you do. It really depends on so many factors that for me it's difficult to give you an idea. Let's talk about life. What's the life expectancy of a drone? Let's say if you handle it in a correct way, it can fly easily 5 to 6 years. We have drones that have been flying for 1,000 hours plus without anything, because the only moving parts that you have is the ball bearings on which the propeller is mounted. So if you change this one on a frequent basis, which is basically say 20 bucks for a ball bearing, then you can keep going. And if you bear in mind that if you are well trained, you can do 30 hectares a day, then I would say start calculating, take the total price, and you can do it for 5 years. I think personnel is the question here. Do you have enough personnel to operate this thing 7 out of 7, 24?
If you allow me, because I've been thinking about the same question as well, and I think there are too many variables that you have to take into account. It's mainly, of course, personnel. What's worth the life? That's the first. Secondly, it's also the use of the land. Is it barren land, or is it agricultural land? Is it land that is cultivated? Is there any buildings on it? So depending on the land, it's also an element that you have to take into account. But the main issue here is that you save man hours by locating the drones. You can be much more, let's say, precise, and you can save on man hours. That's the biggest issue, because demining will still have to be done by humans or by mechanics, of course, but you will be targeting these objects more efficiently.
Such calculation could be good for marketing.
For sure, yeah. Accurate data to start with, and then start.
Yeah, but if you use the time being, you would have some kind of statistical actual field. That would be useful to push the product technology.
That's true. Okay, thanks a lot for the attention. Any more questions? No? If not, then we'll take a look at the drone, which is in the back of the room, and I'll give some quick explanation. We have the node.
After the edit. But the question is, who knows where will be the end? You call it. I think sooner. Look at these 8 decades. Look at what it takes to take about the mine. And I'm talking about the rest of the area. That's the problem with doing a lot of it.
So for demonstrational purposes, we now set the speed to 1.5 meters per second, so that it's not too fast. You can look how it actually works. As you can see as well, for now the drone is flying automatically, flying the lines. We have a separation of 60 centimeters between each line because of the fact it's a really small ornament. The obstacle sensor below is trying to maintain a constant altitude or a constant height. Right now it's not difficult, it's quite flat, but if you like a large change in orography, it's also possible to actually follow up, because distance from the ground is very important. It also loses a lot of time when shifting from one lane to the other. So in order to have high optimization, it's good to have long lines. So then you have the optimum capacity of the system. As you can see, Jonas is not touching the control. And the system basically is now using the RTK that you see over there to perform an action. But again, it's still electronics. If something goes wrong, Jonas is still capable or able to take over manual control. Something's not right. As you can see at all times, not right now, but when it comes back, the green LEDs on the back end side, they are of importance, and that's why Jonas is positioned over there. He needs to have an accurate view on the LEDs. When we go from green to yellow to red, he needs to take control over the drone. It is both. It's now coupled to the payload as well. So if something goes wrong with the capturing, it actually says, okay, I don't get any data from the one. And with the GPR, data is stored in the static. So in the field, it doesn't have change ISD cards, everything is via wireless. Have a look at the data, what we actually have discovered. Yet again, I must say it's like looking at an echo from a baby. If you're not a doctor, in the beginning it's quite difficult to see where the feet and the hand and the heart is. But after some training, which is mandatory, you are able to find your way around and to see where the distortions are taking place. So, this is in general the complete scan. The turning points we already eliminated, so we don't need information where the drone is hanging still because it's an access on info, which requires extra storage data. So these are the lines, and there are a couple of elements where the system itself already says there might be something here. So there's already a bit of AI behind, but I must say in this process it's still about 80% manual labor, 20% via artificial intelligence. So, Jonas, can you zoom in? So we do the background removal, so to have a more clearer view, and we are actually looking for stuff which is positioned in the top layer. So the top layer, okay, this is what we get out. Here we see a distortion, so it's kind of a conic indication. So something tells me that just right below the grass, which is indicated right here, there is an ornament located. So this should need further investigation. You go further. Give it time. Maybe there, but that's not. These are stones and tunnels. Yeah, so this one as well, because it's a lot thicker. So I'm putting myself on the spot right here to make a very fast interpretation. Okay, so this and this position should be it. Yeah. Okay. So Jonas, can you now put it on the general view? So by clicking right here, actually get flags which are positioned, and then in the next step we can overlay with the image that we have created. So we go to QGIS now, we export it. This is a free program that we use, QGIS. It's free around the world. So it encourages people to do georeferencing, geomapping, and so on. Yeah. So we take the satellites, based on Google hybrids. We red dot the position that we actually do looking for. And this should be the two locations where the mines were actually planted. So basically, that's the process that we go through from start to finish. And again, depending on the size of the object, yeah, it's difficult or less difficult in order to see any changes. For me, it's a lot easier to have things that are buried, because right now I'm looking at grass, which gives a lot of distortion. To get something, a deformation out of that, is more difficult than, for example, a landmine, which is buried 10 to 15 centimeters deep. Because the soil there is much more layered, it's much more structured. If you have someone digging there and putting something there, you see that there's a change in the soil. Not sure that we have it right on hand, but for example, in Africa, they also use a lot of things like nitroglycerin, which is in large containers under the ground. Also, that is something that we detect by looking where the soil has been moved around. It gives you a completely different layering of the soil when capturing with GPR compared to normal hardened soil. And that's not what else you want to
Is that just because it's been disturbed?
It's been disturbed, yeah. That's what you're actually looking for. Yeah. John.
Anyway, you said so. You have distortion by the simple fact that there is a lot of grass. Question was raised a couple of minutes ago. What do you do when you have a lot of vegetation, like wild grass, corn, or whatever? In what way is this affecting this distortion, and how?
It makes it a lot more difficult if you have high vegetation. Now, what we can do, for example, if we know the vegetation is, let's say, 1 meter high, or more. It depends. Right now, maybe more. Is that you can eliminate it. Now, with a GPR, if you have to fly at 2 meters, it becomes less and less accurate. So that is kind of a problem. Yeah. But then you use, if the ornament is big enough, you use another sensor at maybe 500 megahertz, and in that case, you can easily fly a lot higher and have still a very deep penetration level.
But wouldn't it be more interesting to do these detections during winter time?
Yeah, for sure. Yeah, there's no question about it.
You have actually a seasonal activity.
That's it. Now, good question. What we designed right now is a GPR which is suspended from a pole, so that you can bring the GPR a lot closer to the ground. You overfly the ground, and it kind of finds its way through the vegetation. So that's now an option that you can add in order to tackle this problem. Yeah. Jean?
Another question was raised by this gentleman here, Jean-Pierre, is what about magnetic bombs? So you apparently have bombs or mines that explode by detecting a metal object.
Yeah.
So how would you solve this? Simply by raising the altitude with which you
for sure, because the amount of metal which is inside the drone is very limited, so it's most likely to be a compound of plastic, carbon, and it's only the small electronic components which are made out of metal. I don't think it's able to detect if a drone is flying 2 meters high. It looks impossible for me. I have no idea what kind of system there is on the market, and maybe there is some enhancement to it, but it's rather, yeah, it's not like a tank passing by with a big magnetic footprint. Okay. So the suspension with the pole, it's something maybe I need to implement in the presentation as well, is something which is, I think a month ago, Jonas, released.
Yeah, something like that.
Yeah. Which could tackle the high vegetation. Okay.
Have you found butterfly mine right now?
Right now?
Yeah.
Two. We planted 2, so yeah, we know where they are lying. So we detected 2 and printed them out. So the white one that you saw, we put 2 white one in the grass. Yeah, so that's what we are actually looking for. And right now, again, I'm putting on the spots. I'm not a computer, so I'm looking at the image. But you can imagine if you can put AI behind it, it's a lot faster than I am, and probably a lot more accurate than actually looking at, is more trained to look for something in particular. And I believe that in a couple of years, this system is capable of saying, okay, with a high percentage of accuracy, it's going to be this kind of ornament or this kind of ornament. If I can do it, a computer can do it faster and better, for sure. So, for that reason, we need further development, start working on it. But what we have right now is already a very good solution to start getting going. I think that's important. And based on what we have, we can improve, enhance, and see where we land.
It's not looking for specific materials, it's more the shape.
It's the shape, yeah. Because if you look at the GBR, it's looking for distortions. And depending on the shape of the explosive, you can say, okay, this is the possible kind of mine that is lying over there with a certain percentage of accuracy. And with the metallic mines, the same thing. Each metallic object gives another distortion of the Earth magnetic field based on its properties, based on the amount of metal, which kind of metal. It needs to be ferromagnetic to be clear. And in that way, you also have a very particular magnetic footprint. Training AI on it can provide us maybe an automatic way of detecting and defining what is lying over there.
Can you explain how you're operating testing in countries in Africa and also Ukraine? Is there any European country interested or looking into your systems to be used?
Right now, we are, I must be honest, mainly focusing on war zones, because there are the resources, there is the need for it, and we know they are serious. It's not something they need to do in the future. They need it right now, and that's why we are focusing on these markets. I'm sure in Europe there will be a lot of interest if we demonstrate it, but it's right now not really our focus point, I would say. I think in other zones in the world they need us quicker, faster, and here I think it takes a lot of time. For example, the Belgian military, you see if we come up with a solution, it takes months in order to get some kind of interest. That's different.
Yeah, I'm here again. I was wondering, and I already asked you this question by mail, what about underwater detection of, I guess that it's not that much of a problem to detect mines underwater, but I think the biggest problem is the accuracy, because you have this flooding of rivers and dams, but still you have a lot of problems in the long term.
Yeah, because they just throw it. I've seen it. They just throw it in the water, right?
Yeah.
They detect it. They say, this is it. We want to dispose it. We put it in the river. Yeah, that's just displacing the problem.
Is this also something that you plan to work on?
Yeah, we're planning to work on, but there are a lot of challenges who come with the fact that it needs to be detected underwater, and then the geolocation, I think, is going to be the main issue and the main objective to solve or crack this question. How to say, okay, that's the location, because detecting, also with this system, detecting is not really the big issue. It's how to get accurately to that location. I can now tell you, okay, this is the location. If you need to go straight for it, you cannot deviate. I think it's not that easy. So I need now to get accurate GPS location. You need an accurate GPS logger, and it shows you where you need to go. That's our modus operandi at the moment. That's how we work. And maybe in the future we can put the GPS coordinates in the drone, let the drone fly over there, drop something, I don't know, whatever solution that there is. But that's next step. So right now it's or verification via dogs or other animals like rats. I've seen also tests with rats.
Other robots, ground robots.
Other robots indeed should also be or could also be a solution in that. Yeah. So for the water part, good question. We're working on it. Alright, I hope this was a comprehensive overview. I hope you have a very good idea what the system can.
What would be used now, if my lack of knowledge, to physically go and get the mine, typically?
Right now?
So you locate where it is, what goes in? Is it a human goes in, or is it a robot, or is it
What I've seen is a dog.
a dog?
Dog goes in, yeah. That's what I've seen what they're doing. And then we did tests with humans going in. This is GPS location, they have a GPS receiver, also connected to RTK, and they go towards the location. We can pinpoint, you can just say latitude, longitude, canal, and they go towards that location. But again, I would think towards the future it's better to let the drone fly over there and in some way detonate this
Well, I
manifold.
was going to say, like, what's ultimately destroying the mine, you know? And if you send it in with machinery, then...
Yeah. In some situations, the destructive way of clearing the mine is not advisable. Again, if it's on roads, for example, or buried underneath roads, if there's no asphalt on top of it, it's a problem. In Africa, for example, they don't want to explode it because they need to close down the road and it takes weeks to get it going again. So there, it's not an issue. But I can imagine in an agricultural field, let it detonate it. I think that's the fastest way to solve the problem.
But then again, you also have a problem of pollution. So the chemicals within the mines are also, let's say, a problem in the long term.
Yeah, it goes into the soil. That's also a lot of challenges when I hear the questions. So that's good, and I would say let's look for solutions together. Try to clear the mess as fast as possible, I would say. Okay, I would think that concludes everything. I would like to invite you upstairs. Paul has prepared something for us as somewhat of a get-together afterwards to get some informal knowledge, to get to know each other. If you have further questions, feel free to address me. I will be happy to answer. Also, my colleague Jonas is happy to answer any questions related to the technical aspects of mine detecting. Thank you very much.